So for this problem, we want to show that the average field inside a sphere of radius r due to all the charge within the sphere is -1 over 4 pi epsilon naught times p over r cubed, where p is the total dipole moment. There are several ways to prove this with simple results. Here's the method. So number one, they want us to show that the average field due to a single charge q at a point r inside the sphere is the same as the field at r due to a uniformly charged sphere with the density of negative q, with the charge density of negative q divided by 4/3 pi r cubed. So we want to draw our sphere, and we have some point charge. P, and this would be our radius r. So now we want to write an expression for the average field due to the point charge at q with that distance r. So our electric field average is equal to 1 over 4/3 pi r cubed e d tau. So now we want to substitute. The average that they gave us in for E and solve. So E average is equal to 1 over 4/3 pi r cubed times the integral of 4 pi epsilon naught q over r squared rd tau, which then equals, you pull the constants out, 1 over 4/3 pi r cubed, 1 over 4 pi epsilon naught q over r squared r d tau. Which then can be further simplified to just q over 4 pi r to the third is 1 over 4 pi epsilon naught integral 1 over r d tau. So now put it in terms of rho. So you get rho 1 over 4 pi epsilon naught integral 1 over r squared r d tau, because we know that rho is equal to q over 4 pi r cubed. So now we can simplify even further, and we would get 1 over 4 pi epsilon naught integral rho 1 r squared r d tau, which would just simply equal 1 over 4 pi epsilon naught rho over r squared which equals E rho that we had. So E rho is equal to E average. So that checks part A. Part B. Now the latter can be found from Gauss's law. Express the answer in terms of dipole moment at Q. So we want to write the expression for electric field inside a uniformly charged sphere or charge density rho. So we have E rho again is equal to 1/3 epsilon P R. Now we want to sub in our rho that we have from up top. So we get E rho is equal to 1/3 epsilon naught negative Q over 4/3 pi R cubed times R, which is equals negative Q over 4 pi epsilon naught R, or R to the big R to the big R cubed times R, which equals negative rho over 4 pi epsilon naught R, big R cubed. Thus, we can see the electric field due to the dipole moment. This answer here, which checks off part B. Part C, you want to use this superposition principle to generalize to an arbitrary charge. So you want to write the expression for the sum of charges, for the sum of the individual average electric field. So we have E average is equal to negative P over 4 pi epsilon naught R to the third. And that is the sum of all of our superposition charges. And that gives us verification on part C. And lastly, part D, where the charge Q is placed on the outside of the sphere. We're going to show the average field over the volume of a sphere and do the charge on the outside. Okay. So the charge Q is placed on the outside of the sphere at R. So we know that our E average is going to equal 1/4 pi epsilon naught times 4/3 pi R cubed rho times R squared times R. And then we know it's a uniform, due to it being a uniformly charged sphere, that R rho is going to be 1/4 pi epsilon naught plus negative Q over R squared R. And that will be the average electric field outside the sphere due to a point charge that is equal to the electric field, the same charge produced at the same center of the sphere. And that will be our last answer, which all verify that the average field inside a sphere of a radius R due to the charge within the sphere is negative 1/4 pi epsilon naught P over R thirds, because we got that for every single part. Thank you for watching this question.